We have already spoken about the entity relationship modeling when we were covering the steps in the database life cycle. It came as part of the logical database design and it was in the conceptual part. In this section, we would be covering the entity relationship modeling in detail. Now, before we jump into the nitty-gritties of this topic, let us just have a look at the terminologies that we'll be using while we cover the slides. Entity. Now, what exactly is an entity? We can define entity as a thing or an object that exists in the real world and it's distinguishable from all the other objects. It can be anything that is of interest to the system and it exists in the business world. We'll take an example. Let's say student is an entity because it can be distinguishable through its roll number. A university becomes an entity because it exists in the real world and is distinguishable by the university code. An employee again is an entity as it can be distinguished through its employee code or employee ID. An organization also exists in the real world. It is of interest to the business system and it is distinguishable from any other organization. Now, let's take all the students that belong to Harvard University. Now, since all these students have the same share of properties and they also are of the same type, they constitute what is known as an entity set. So, an entity set is nothing but a set of entities of the same type and that share the same properties or attributes. Now, what exactly is an attribute? Just take it up in the... Let us consider the entity student. Now, this entity will have a lot of properties, as in the roll number, the name of the student, the course for which he has applied in the university, and the semester to which he has been assigned. There can be a lot of other properties as well. So, all these clubbed together forms what is known as an attribute. So, an attribute can be defined as the descriptive property that is possessed by each member of an entity set. Now, let's take an example for roll number. A roll number can be a combination of the course as well as the semester to which the student has been assigned. So, there is a particular value set that can be assigned to an attribute. It gives us a description of the permitted values for that attribute. And it comes to be known as the domain for that attribute. There's another very interesting term that comes in the entity relationship modeling. It's the second part, the relationship. When we speak of relationship, it is nothing but an association among several entities. It describes how different entities are connected or related to each other. Now, when we are talking of relationships and how entities are connected to each other, there is one very important concept that will come into the picture, which is known as the mapping cardinality. Now, a mapping cardinality is nothing but the number of entities to which another entity can be associated via a relationship set. We'll take an example so that it becomes a little more clear. Now, let us take an Indian citizen. This becomes an entity. It has becomes a relationship, a PAN number. Now, each Indian citizen can be assigned only one PAN number. Also, each PAN number can be assigned only to one citizen. So, this represents something which is known as a one-to-one relationship. So, if you have to define one-to-one, it means that an entity in A is associated with at most one entity in B. Also, an entity in B is associated with only one entity in A. This is a one-to-one mapping cardinality. Let's have a look at the next example. Let's say there is a customer. It opens a bank account. Now, I can have one customer opening more than one accounts in a particular given bank. The type of accounts might vary, but the customer remains the same. So, one customer can open multiple accounts in a bank. However, each account number is associated with only one customer. Let's rephrase it. Each account number can only belong to one customer. An account number cannot be mapped to more than one customer. So this type of a relationship is known as one-to-many. So we can define a one-to-many relationship as in an entity in A is associated with any number of entities in B, which can be even 0. However, an entity in B is associated with at most one entity in A. Let's consider another example. A film has actors. Now, an actor can be casted in multiple films. Also, a film can have multiple actors. So this kind of a relationship becomes a many-to-many relationship. We can define it as an entity in A is associated with any number of entities in B. Also, an entity in B is associated with any number of entities in A. So a mapping cardinality can be of any one of these types. Now let's look at the symbols that are used in an ER diagram. The first symbol that we have here is a rectangle. It is divided into two parts and this represents an entity set. The first part contains the name of the entity set and the second part contains all the attributes of the entity set. Now here we have taken an example of the entity set salesman. His attributes are salesman ID, salesman name, the zone, customer ID, supplier ID, so on and so forth. Attribute that forms part of the primary key has to be underlined. In this case, we have salesman ID which uniquely identifies a particular row in this table. So this becomes our primary key. If it is a composite key, that is, there are more than one attributes which are together contributing as a primary key, all such attributes need to be underlined. The next symbol that we use is a diamond symbol, which is used to represent nothing but a relationship set. Now, when we have this rectangle and this diamond, we need to connect it. That is done through lines, which is nothing but linking entity sets to relationship sets. Now, let's take a look at this table. I know this table is familiar. We've already had a look at it when we were covering the requirements gathering and analysis. Yes. So we had the salesman ID, we had the salesman name, we have the sales zone, we have the customer ID, we have the customer name, the supplier ID and the sales amount. Now I want you to quickly pull out a pen and paper and list down all the different entities, the entity sets, the attributes and the relationships that you can make out from this ER diagram. So if you are done, we'll have a quick walkthrough of what all entities can we figure out. Yes, we have the salesman, we have the customer, we have the supplier. Now each salesman that is belonging to a particular zone, let's say the west zone, becomes an entity set. All the customers for a particular salesman become another entity set as customer for a given salesman. All suppliers which deal with a particular salesman also belong to one particular entity set. Now, entity sets can be as many as and when required. It completely depends on the business at hand. When I have a first look at this table, immediately I can make out that there's a salesman, there is a customer, there is a supplier. Maybe at the back end, I also figure out that there is something as a product. Since each product is distinguishable, that again goes on to become an entity set. And we can club the same type of entities and form what is known as an entity set. Now, let's take the entity salesman. For this, the attributes that are available are the salesman ID, the salesman name, the sales zone, the customer ID, the supplier ID. So these are the properties that have been assigned to the supplier, to the salesman entity. Now, a very simple relationship that exists between the salesman and the customer is sales. A salesman sells products to the customer. The supplier supplies goods to the salesman. Now, I would again want you to pull out your pen and paper and quickly draw this ER diagram according to your understanding. Now, let's have a look at the ER diagram. Are you anywhere close to it? If yes, then that means you've understood the concept of ER modeling. So you can pat your backs. Yes. Now we'll quickly summarize whatever we have learned in this ER modeling. It logically represents and analyzes the components of the business system. So I have the supplier, the salesman, and the customer. The salesman sells goods to the customer. The supplier supplies products to the salesman. It is very widely used because it's very easy to construct and understand. The ER model specifies the entities that are there in the database, the relationships among these entities, the constraints on the entities and the relationships. We have already covered mapping cardinality. Yes, that's one type of a constraint. And the attributes that are existing with each kind of entity set. The interrelationships among the various components or various entities are very clearly visible with the help of ER diagrams. Also, when we are constructing ER models, it is independent of the software and the hardware considerations. Now, we use ER models basically to design databases. That is, it is used in the conceptual part of logical database design. Its utility does not lie in implementing databases, because any kind of high-level data manipulation language like SQL cannot be performed using an ER model. So once we have our ER model in place, the next step is to translate this into a relational model for implementation. We would be taking this up in the next section.